The functions f and g are defined by the given equations, where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines where x is greater than or equal to 0? This is a confusing sounding question, but if I just break this down to its bare bones with you, if you see this, don't overthink it. All it's saying, maximum value of an exponential function. Let's take a quick look at each of them. This is 0.4 inside of the parentheses, meaning it's a decay function. This is 0.4 inside of the parentheses again, so we have two decay functions. What that means is if I were to graph both of these, I would be starting somewhere up like this as a y-intercept and going downwards like that. So we know that the maximum value is going to happen where x is equal to what? 0. And we're also told that x has to be greater than or equal to 0. So this is to confirm that we are starting high and going lower. The next component that we want to be aware of is if x is going to be 0, when you plug in 0 into both of these equations and you plug in 0 for x in both of them, which of these answers is going to simplify down to either the constant, this is the constant, they're both 33s, or second option is either that or get the coefficients. The coefficients would be the 33s or the 0.16. So let's actually apply this knowledge. We're going to simply plug in 0 into each of these functions. So the first one, make the x plus 3 a 0. 0 plus 3 is 3. So we would have 33 times 0.4 raised to the third power. When you do the math for this one, you'll find that you don't end up with either the 33 or the coefficient. So 1 doesn't work. Any answer that features 1 then cannot be right. So we can eliminate A and C at this point in time. Okay, so now let's plug in 0 into the second equation, this one over here. Plug in a 0 for x, so we're going to end up having 33 times 0.16 times 0.4 raised to the power of 0 minus 2 is negative 2. We plug in a 0 right here. But remember, when you have a negative exponent, oh, you know what? You can just plug this in your calculator. That's probably the easier thing to do. But I'm going to show you manually as well. So 33, 0.16. If you have a negative exponent, you can move it to the denominator. So down here, we now have 0.4 to the second power. And if you realize this answer is the same as that one. So we did end up with a constant. So for the second equation, we do end up with a constant. So 2 only would be the correct answer.